Hi guys, this is Leela. Welcome to my channel Leela Webdev. In this video, we will try to learn about the order of passing arguments and also about the library functions, how we will be using and mismatched arguments in the printf and the return type of the functions. We'll try to see about this one. Now let's try to understand about the order of passing the arguments in the function. So we need to understand about this one. So key point is the order in which the arguments are passed to a function is compiler dependent, not strictly defined by the language. So that is the main thing. So for example, let's say that here you will be able to see a simple code I want to show you. So int a is equal to 1 is there and I am using a printf %d and I am passing a plus plus a and also the a plus plus. Here a is modified within the argument list. The values passed to the printf depend on the order of evaluation by the compiler. Common misunderstanding is one might think that it will print a 2 2 will be printed. Actual result will be 3 3 and 1. So how it is, let's try to see it. So normally it will happen right to left evaluation as chosen by the compiler. So first one will be a plus plus, evaluates to 1, then increments a to 2. So plus plus a increments a to 3 and evaluates to 3. The value of a is now 3, so the last argument is 3. So that means it will be happening from right to left. So first a value will be 1, it will print 1 and then increments to 2, then it will increment to 3 and then it will print 3, and a normally it is a3, it will print 3. So these values will be 1 3 1 comma 3 comma 3 are passed to printf. So here it will be passed to 1 comma 3 comma 3. So that is one thing. So now here printf prints them in the order they appeared in the format using the in the string like 3 3 and 1. Writing code that relies on the order of argument evaluation leads to unpredictable behavior and is considered a poor practice. So this is one thing which you need to understand. The second one which I want to tell you is the using the library functions. So here this the second one. So now you understood about this concept. So second one is the library functions. Library functions like sine, cos, etc. need their prototype declared to inform the compiler about their usage. So for example, let's say that, so here this is our example code. I will try to show you. So we need to use this math.h include prototype for math functions like sine, cos, etc. And here you can use the sine like this, it will be mentioned here in this math.h. Now if these prototypes are missing, the compiler cannot verify whether the correct type of argument and return values are being used or not. So here we are using header file studio.h, input output functions like printf, scanf is used, math.h, mathematical functions like sine, cos, power, etc. has been used. For example, let's say that I will try to show you a simple example for this one. So here this is our example. So without using math.h, the compiler won't recognize the functions or verify their correct use. So here you are using studio.h and math.h. And here we are using float a is equal 0.5 and we are using sine, cos, these all things, right? So these methods, these functions, declaration, all those things are mentioned in the math.h. So without using this math.h, then the compiler won't recognize these math functions. So the third one which I want to tell you is the mismatched arguments in the printf. Okay, so mismatched arguments in the printf. I will try to print here. Yeah, printf accepts a variable name of argument, variable number of arguments. So mismatches in format, specifiers and variables may not result in the compile time errors. So it will not result in compile time errors. I will try to show you some simple examples for this one. So here the first one, printf may print 10 20 and a garbage value where garbage comes from the undefined memory. So here we are having 3%d and we are using only the missing one variable, and here we are having only 1%d and we are using 3 or 2 variables, extra variable j without a format specifier we are trying to use it. So if you want to use this one, so for example, let's say that, so we are using this value, right? So let's try to go into this one. Here I will mention these two things and here I will use, and here I will use int I is equal to 1 and int j is equal to 2. Let's assume, and if you try to run this one, so here you will be able to see some garbage value has been printed and this one is omitted. And the second one, printf will be ignored j because will ignore j because there is no percentage d for it. So now always ensure the number and type of format specifiers match the arguments passed to printf to avoid the unpredictable outputs. That is one thing. The next one which I want to tell you is the return type of functions. The return type of functions. The functions in C have a default return type of int unless explicitly specified otherwise. Example for this one is, for example, let's say that you are having float square of float x and you are returning x into x, returns a float value. So here, if the return type is not explicitly declared as a full float, the compiler assumes that the function returns an int. The return float value will be truncated as to an integer, causes errors in the output. So for example, let's say that here I will try to show you a simple example for this one. So here we are having a float square float of x and return x into x we are using, and int main float a is equal to 1.5, and here we are printing the value percentage to f and return 0. Now if I try to print the value for this one, so here you will be able to see 1.0 and 2.25. So that is one thing. Why precision matters? So precision matters also you need to understand very clearly. So this precision thing. Using the correct data types and prototypes ensures accurate calculations and prevents truncation or rounding errors. Example, using a float for precise decimal calculations, including appropriate header files math.h for mathematical operations. So these are the precision matters. So normally the general takeaways, what I want to tell you is, before closing of this one, order of argument passing. Avoid writing code that depends on the order of argument evaluation. Compiler differences may lead to the unpredictable outputs, and we need to use the prototypes. Always include the necessary header files to declare the library functions. Prototypes help the compiler check the validity of the arguments and return types. Printf mismatches. Ensure format specifiers and arguments lists match exactly. Debugging mismatch of printf statements can be tricky. And the return types. Explicitly specify the return type of functions to avoid surprises. The default return type is int. So whenever you don't mention the return value and you are returning some value from the function means then the return value for this one is int. So that's it guys about this functions concept which I want to tell you about these things. So I have told you about the order of which how you pass the arguments, and I have shown you about the library functions also like sign double and header files how it will deal, and I have explained you about the mismatched arguments in the printf. If the printf arguments and all those things are mismatched means then how the compiler will take this one. So it will not throw any compile time errors, it will print the garbage values. And another one is return type of the functions. So float square and all those things I have shown you. So if you don't mention it, by default value it will be int. And the precision thing I have explained you. So hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you.